Start recording. There we go. Okay. Page 89. So, reaction mechanisms. We will be looking at potential energy diagrams for multi-step reactions. So we're putting together the potential energy diagram with the reaction mechanism. Okay, so combining two things. Okay, so in a multi-step reaction, what do we call a multi-step reaction? That is a reaction mechanism. Okay, so in each step of a mechanism, they each have their own activated complex. If you remember last day when we said each arrow had like a little star above it. So each step has its own activated complex, which means that each step has a peak. Yes, because the activated complex is at the peak. So each step has its own peak. So if you have 3 steps, you will have 3 activated complexes and 3 peaks. The higher the peak, can you guess what happens to the speed? If the peak is higher, the step is faster or slower? If we have a higher peak, it's going to be slower. Yes. Okay, the slower the step. Now, I'm going to make a little extra thing here. It's the higher you are from the original energy. Okay, from the original reactant energy. And the activation energy is the difference in potential energy from the reactants to the highest peak. So if you want the overall activation energy, that's going to be the potential energy of the highest peak minus the potential energy of the reactants. The slowest step is called the, tell your partner, what do we call the slowest step? Yes. Why is the highest peak the slowest? Let's just look at a single step reaction. Or are you good? Oh, never mind. Sorry, I thought you just had an epiphany, but apparently not. I was misreading. Which reaction is faster? First one, why? Lower peak, therefore a larger percent of collisions have enough energy to form that's an R, doesn't look like an R, sorry, form the activated. The reason I'm putting it like this is because now we're going to be looking at steps in a mechanism, okay? So we might not be forming products or reacting like all the way. Which of those ones is the rate determining step? If we have 3 steps, tell your partner, what do you think? Who is the rate determining step out of those 3 steps? 3 peaks, 3 steps, 3 activated complexes. One, two, three. Oh, am I not plugged in? What's happening here? Why is it not plugged in? Hold on. Not plugged in here. That's on. Sorry, I just have to. Oh my God, it's come unplugged here. Okay, hang on. Ay. Okay. Love technology. It's awesome. Other than when it's not. There we go. Okay. That should do it. All right, good. No, you guys don't know which one is the rate determining step? You're going to hold up the number of fingers for the step that you think it is. 5, 4, 3, 2, vote.
1.
1. Yes, it is 1. Okay. 1 is the rate determining step. What is the overall, I shouldn't point at it like that. That's going to take space that I want. What is the overall activation energy for this reaction? Here's my reactants. Where would I start my activation, my EA arrow? At the reactants. And where would it go to? Top of the first peak. If the particles have enough energy to get over the first peak, they certainly have enough energy to go over the second and the third peak, right? Okay. And it doesn't matter where you put the tallest peak. You can put it first, you can put it second, you can put it third. You have to have enough energy to get over that peak. And if you have enough to get over that one, you have enough energy to get over the shorter ones. Okay? All right. Okay. So back here. All right. The slowest step is the rate determining step. That has the highest peak. The delta H, nothing happens to delta H. You still do delta H the same way you always did. It's between the reactants and the products. We just ignore all the little bumps in between. Okay? Delta H. There we go. If a collision has enough energy to get over the highest peak, it will have enough energy to get over all the other peaks as well. You might see something that looks like this. Does it matter that this one goes really low here? If you imagine a ball, when it goes to the top of the hill, it loses kinetic energy and it gains potential energy. When it rolls down the hill, what happens? It gains kinetic energy and loses potential energy. So if the ball rolls all the way down here, what has happened to its kinetic energy? It's gotten higher and higher and higher. So it will have enough to get over this peak as well. Okay? So it's not just like, oh, this is very tall. That's nothing. Okay? That it doesn't matter because it will pick up energy as the particles will pick up energy as they separate from one another. Okay? Even though the ball goes very far down into the second valley, it picks up a lot of kinetic energy velocity. I don't know why I said kinetic energy velocity. That's not a correct way of phrasing it. It's maybe slash velocity. In the process of going down that second hill, this kinetic energy, or velocity, allows it to get over the third hill, even though the third hill is very high. So that's just saying in words what we saw in the picture. Okay? So, the activated complexes, remember they happen in the arrows. So we have them 1, 2, 3. Here we have 1, 2, 3. Now our reaction intermediate, Huber, is formed after the first step. So right here, that's Huber. Yeah? And then Huber forms star number 2. Yes? And then it reacts to form Hober. So where is Hober? Hober is in that second valley because it comes after the second activation peak. And then finally, we get the third activated complex there. And then finally, we end up at our products. And you can see once again, who is the, what am I trying to say? I'm trying to say, who is the rate determining step? Thank you. Number 1, yeah. Okay, that one's not particularly obvious, but it is number 1. Okay. Activated complexes occur in the peaks. Oh, it's supposed to be highlighter. That did not work. Activated complexes are in the peaks. The reaction intermediates occur in the valleys. You can also call them troughs if you prefer. Either way. I would like you to define to your partner the term reaction intermediate. Please define the term reaction intermediate. Okay, so a reaction intermediate is a substance which is first produced in one step, and then second, it gets used up in a later step, okay? The steps do not have to be consecutive. You can produce something in step 1 and use it up in step 3, okay? So that's okay. So they do not have to be consecutive. You can produce it in step 1, use it up in step 3. Totally fine. So we went over this last day, but we're reviewing it today because we're going to do something today that is the opposite. Something that appears first in the reactants and then in the products. But this one appears first in the products and then in the reactants. So a reaction intermediate appears first in the products, and second, it appears in the reactants. And if you see something like that, that is a reaction intermediate. Okay? Catherine, could you close the door for us, please? Thank you so much. We've got something going on. I don't know what those things are out in the hallway, but people are having to go around and point iPads at them and phones at them. So now, our new thing that we're going to look at in reaction mechanisms is the catalyst, because very often catalysts, remind me, what are the 2 things you need in your definition of a catalyst? A catalyst provides an alternate pathway with a lower activation energy. And often that alternate pathway is a multi-step reaction mechanism, okay? So it provides an alternate pathway with a lower activation energy. And one of the things, if you're looking for a definition, you also need this, and we have not talked about this yet, so we're going to add this. 1, it provides an alternate pathway. 2, it has a lower activation energy. And 3, it is not used up in the reaction. You need all 3 in a definition. Do you guys remember the matchmaker from the little video? Yeah? So if a matchmaker goes and says, hey, you over there and you over there, get together, go on a date to the dance. Have we used up the matchmaker? No, they can go on and say, hey, you over there and you over there, get together, go to the dance. Yes, and they can keep catalyzing reactions because they don't get used up. They do the matchmaking and then they're like, okay, off you go. And then they are back and then they say, okay, well, I can catalyze another reaction. So a catalyst, rather than being produced, it is first used. But catalysts are not used up, therefore they are reproduced, second, in a later step. So it is the opposite of a reaction intermediate. So if you are going to recognize a catalyst, here's A. Okay, it is first in the reactants. And second in the products. And now it can go off and catalyze another reaction. So let's compare the two. Reaction intermediate appears something blue. Oh, blue. Come here, blue. There we go. First on the right, then on the left. A catalyst appears first on the left and then on the right. And if you have trouble remembering that, just remember the catalyst can then go off and catalyze another reaction. You end up with catalyst, so it can go and catalyze another reaction. Reaction intermediates are used up as the reaction it proceeds. Catalysts are not used up as the reaction proceeds. Yes? It doesn't have to be on the last step. It could be on the second to last step as long as it's produced like in a later step. So it could be here. We could have A come out here. Oh, I'm sorry. What was I going to say? If it's a two-step reaction, then yes. But if it's a three-step reaction, it could come out in step 2 and then go back and be like, let's say we had, I don't know. Yeah, but watch. Okay, so we had A plus B goes to C plus D. C plus E goes to B plus F. And then we have, I don't know. This is hard to make one up on the fly. Okay, we got D plus, I don't know. Anyway, you could have a third step, and this would be a catalyst. Yeah? So it doesn't have to come out in the last step. It could come out just any step that's lower down. Okay? But it's always in the products at the end. Okay? The catalyst always finishes in the products. So what I would like you to do is I would like you to take a look at this reaction. Here we have an uncatalyzed reaction, which will be the same as the overall reaction. And then we have it catalyzed with H+. So I would like you to identify all the reaction intermediates and any catalyst that we have in this reaction. I need to change the font on this. I don't like it. When you have done that, I want you to check with your partner, see if they got the same answer as you did. You're so happy? Oh. Doesn't getting rid of something you don't need and is just causing you major stress, doesn't that feel like the best?
I know, and then now I'll just, be so into chemistry.
Right?
Oh. At all.
I remember.
You don't need it.
Not if you're not going into sciences.
Pardon?
If you're going into sciences, you need it. But if you're not going into science, no, you don't need calculus. Yeah. Right?
Yeah.
Yeah, just make sure you check whatever program, but I'm pretty sure you don't, right?
I don't even see math as an option.
Yeah. So,
Do you think? You probably.
well, I have a degree in biochem, so yes, we had to. It was okay. It was no. I mean, it was okay. I didn't enjoy first year calculus because I had not yet learned how to do university.
Yeah.
And I wanted to understand. And they kept giving us these basic principal theorems. And I tried to understand them. And they did not make any sense. The delta epsilon theory. I don't know. Okay, so my secret to doing university is when something is too hard to understand, recognizing that it is too hard to understand and just learning how to do the problems.
Oh.
Yeah? Because yeah. So I had always sort of gotten by understanding. I'm like, I understand it. So I can like do things. So I assumed I would still be able to understand things, but apparently I could not. My brain had hit its limit, right? Its limit. Ah, that's a funny calculus joke. Did you guys get that? Okay. Yeah, anyway. So yeah, that's the secret. Plus, I told you guys the other day, right? Go and make friends. Yes. Yes, make friends with smart people. You can make friends with anybody else you want to. That's also fine, but go find the smart people and make friends with them. Yeah. It's good to have lots of friends in university anyway, because you will need emotional support. Because when you are crying, because it's like my midterm was so hard, unless you're taking the arts, in which case, oh God, you'll have papers to write, but it's just not the same. Okay, all my friends were in the arts and they all went out and did things. And I'm like, I'll see you later. I got to go study. Bye. Right? So yeah, it just wasn't the same. Anyway, sorry, got distracted there. Who is a reaction intermediate? HCOO, H2 plus. Okay, so there is a reaction intermediate. There it is. Any other reaction intermediates? HCO. And do we have any catalysts?
Yeah.
Yes, we do. We have an H plus. Okay, so when we go to add up our reaction, we just cancel out our intermediates, and we also cancel out the catalysts because they appear on both sides as well. And we add everything up and we say, what do we have left? We have an HCOOH. Oh, that's it on the reactants. And in the products, we have an H2O and a CO. And if we look, oh, that's identical to what we had before, so that's a good thing. Now, just before we go to the next page, over here, is this endo or exothermic? Let's assume it's endothermic. Okay, I don't even know. I'm just making it up. We're going to draw a potential energy diagram for this uncatalyzed reaction. If you had to draw the pathway for the catalyzed reaction, I want you to think, what would you draw? Have a chat with your neighbor. See if you can puzzle it out. Would our reactants be any different than they are? No, reactants will be the same. So if I'm going to draw my catalyzed reaction, I mean, I can't draw it right on top because it won't look pretty. You know what I mean? Like they should really overlap like this, but I can't draw them like that. So I'm drawing one just slightly. Yeah? Does that make sense?
Yeah.
Yes? Thank you. Okay. Now what happens? What happens to the height of the...
Lower.
It gets lower. Now, is there anything else I should do with it? I went from having this thing here to having these things here. What do you guys think? It needs to be more bumpy, yes? Because we don't just have one activated complex. How many activated complexes do we have? 1, 2, 3. So how many bumps? 3 bumps for 3, 1 for each activated complex. So, and do you have any thoughts as to which bump should be the highest? The second one, because it is slow. Okay, so what that's going to look like is we're going to go up. And I'm going to make my second peak the highest. And it doesn't really matter where the other ones go. You could make the first one the second highest or the third highest. It just doesn't matter. Okay. And then it finishes at the same place. Okay, now let's say you had 7 steps in this reaction and you could not fit them all underneath. You could go beyond it just because it's awkward. Do you know what I mean? Like you could, it's fine. Because it's not, we don't really have time along the x-axis. We just have progress of the reaction. So if we're a little out, we're not going to worry about it. Okay? All right. Oh, look at this. Here's our reaction intermediate catalyst. You can look at that if you want to. Oh yeah, actually, why don't we take a second and look at this? Are you guys familiar with carboxylic acids?
Yeah.
Did you learn about them in Chem 11 or did you learn about them in biology? Both. Perfect. How many people have not heard of carboxylic acids? Everyone has? Oh, a few people haven't. So we're going to just talk about them very briefly, okay? Not a big deal if you don't really know about them. But what we have here is we have this COOH. When you see that COOH, that tells you that group is called a carboxylic acid group. And I don't know if you remember from organic chemistry, but what is the prefix meaning 1 carbon? Anyone know? Meth? Okay, methane has 1 carbon. And this is methanoic acid because it has 1 carbon. So what we do is we take the name methane, which is the name of the alkane.
Oh, yeah.
Okay, and don't worry, this is not tested. It's just that, you know, when you go off to university, like if you don't know any organic chem and you've forgotten it all because you haven't seen it in a year, you'll be like, whoopsie. Okay, so methanoic acid, we add that anoic acid. And then what if we have 2 carbons? The prefix is F. So you can have ethane. Okay, ethane. Just looks like this, carbon, carbon, and all of these little things attached to it are hydrogens. Okay, so that's ethane. If we wanted to change that to ethanoic acid, we would still have a C and a C, and we would have H's everywhere, H, H, H. But then on our last carbon, we'd put a double bond O and an O and an H, because that is our COOH group. Okay? And these are acids. Yes, sorry. No, because you have a table of acids in grade 12 in your pink data sheet. So, but just so that you know what's happening, because sometimes when we get to acids, people get confused, because what do acids have? All acids, not just these ones. They have an H, and the H comes off in solution, right? That dissociates, yes? Well, these compounds have a lot of hydrogens. We have a hydrogen here and here and here and here. Only one of them comes off. I'd like you to guess which one actually dissociates. The one on the COOH. Okay? So when this dissociates, this is the hydrogen that dissociates. So do you need to know that one carbon is meth, one carbon is F, and 3 carbons is bute? Oh, 3 carbons isn't bute. 3 carbons is prop, meth, eth, prop, bute. And if you need to remember that, one of my students, like not for this year, but if you ever need to remember it, one of my students came up with a mnemonic device: me eat peanut butter. But if you're allergic to peanuts, you could change it to me eat pita bread. Okay? Anyway, here you can see ethanoic acid, we have 2 carbons. Propanoic acid, we have 3 carbons. And butanoic acid, we have 4 carbons. The only thing we're changing there is the length of this carbon chain on the left-hand side. Okay? But, like I said, do you need to know that for grade 12? Not really. It's an aside, which means that, oh, set that aside if you don't want to learn it, okay? But this is what the dissociation would look like for a carboxylic acid. This is the hydrogen that comes off, the one on the COOH. All right, and if you want to see what that looks like, it looks like that. Anyway, that was nice. Moving on. Now, once a catalyst is used, it is always what? It does not get used up. What happens? It gets used, but then it gets produced. It is always reproduced in a later step. So what that means is that a very small amount of catalyst can catalyze a large amount of reactant. So you only need a small amount of catalyst. Okay, the analogy is the matchmaker. She doesn't get used up. She can go around matching people. That's actually quite sexist. Why couldn't the matchmaker be a man? Anyway, I don't know. Just realized. Okay. Now, if we have a potential energy diagram for a catalyzed reaction, to find the activation energy of a particular step, you go from the beginning of that step to the peak. But if you want to go the activation energy overall, you don't go from the beginning of that step, you go from the potential energy of the reactants to the highest peak. So down below, there's a picture, and you guys are going to answer these questions. When you have answered them, you are going to check with your neighbor. If you get stuck, you're going to call me over. I got that wrong. Did you guys get the same thing as I did for the activation energies? Hopefully. So, activation energy of the second step starts from the beginning of the second step and goes to the peak of the second step. But the overall activation energy, which is really the most important one. So if you never know how to do EA2, no big deal. You could choose to ignore this. Whoops. Because I don't think it's going to come up very often. I don't ask questions about it very often. What I do ask questions about fairly often is what is the overall activation energy, and that one starts at the reactants and it finishes at the peak, the highest peak. That's our overall activation energy. Where would we start to draw the delta H? At the reactants. And where would we finish? At the product. So we're going to start here and finish here. And that's our delta H. If you wanted to, you could have this come over like that, and you could label delta H like that. Okay, it doesn't matter which side you do it on. And the axes, what should we label the x-axis? Progressive reaction or reaction proceeding. And what about the y-axis? Yes?
Can you say reaction progression?
Reaction progression, love it. Yes, as long as it makes that sort of, yeah. Reaction progression, that sounds good. All right, any of those are fine. What do we label the y-axis? Potential energy, and what's the unit? Kilojoules per mole. Okay? And let's label our activated complexes. How many are there? 3. 1, 2, 3. And where would we label our reaction intermediates? Those would go in the valleys. Okay, so there and there. And that's that. Okay, so everything's like shown here. We already did this Okay, but here's a lovely picture as opposed to my drawing. Three-step catalyzed reaction mechanism versus the uncatalyzed reaction. So here we have the purple is the uncatalyzed reaction and the green is the catalyzed reaction mechanism. Now, what if I tell you a reaction is catalyzed, but I don't tell you how many steps it has? Then you can just be like, okay, well, since you didn't tell me, you can be like, fine, I'll just make it lower, but I don't know what the steps are. So if I don't tell you how many steps, just make one. If I don't tell you how many steps, one peak is okay for the catalyzed curve. What if I do tell you how many steps there are? Then you'd better draw that many peaks. Sorry. Oh, I'm running out of room. Draw that many peaks. Okay, so if I say it's a 3-step reaction, you draw 3 peaks. If I say it's a 4-step reaction, you draw 4 peaks. Okay? But if I don't tell you how many steps, 1 peak will be fine. Oh, look, I said that on the next page. If not given the catalyzed mechanism, just draw 1 peak. Okay, there we go. Oh, do Hebden, page 30, number 55, and 34, number 56, 57, 60, and 61. Plus, guess what I have for you? I have a reaction mechanism worksheet A. This is really good for practicing finding the intermediates. Oh, look, we have find the overall reaction. When we get to question 4, you're finding step 3. When we get to question 6, we're finding step 1. So if you find it easy to find the overall reaction, you might start with the ones where you have to find the step, the missing step. Those might be more challenging. But if you're like, I don't know, finding the overall reaction, that's my level at this point, start with those and then work your way to the ones where you have to fill in the step. I'm going to give you some time to just work on that right now, okay? Ask me questions. If there was anything from the homework that you didn't understand, like you're like, I don't know how they solve for that step, let me know, can help you out, okay? Because your quiz is on Tuesday, yes.
How's the test going?
Oh, your test, like on Friday, next Friday, there will be multiple choice and there will be written response. There will probably be, I'm guessing, 20 multiple choice questions and then 14 written response marks. So it'll be out of 34. Okay? Pardon me? We've finished the unit. Everything else is just practice. Yeah? So anything we've not done is just practice. Okay, so in a normal class period, I give 36 questions, okay? And to be frank, I used to give 40, and people had to finish in the time. But now people are all like, I can't finish, I can't finish, I can't finish. So yours is gonna be out of 34. I would make it less if it were one of the harder tests, but reaction rates is always the fastest, okay? Hi. Oh.
Says she's at the
She saw, oh, okay. I have not seen it. Let's just check that it didn't get popped in here. No, okay. You're welcome to look around. I have not seen it though.
For this reaction right
Yes.
here, yeah? Would this be the catalyzed or uncatalyzed reaction? So how would I differentiate?
Okay, so this is uncatalyzed and you know it because I've told you.
Right, okay.
Right? And then this
And
is
this
the
is
catalyzed reaction because I've told you.
So because so when we write out the catalyzed reaction, we always write out the reaction, or is that?
Pretty much, yeah.
Alright,
I mean,
good.
there are other types of catalysts, but we're not gonna worry about them this
Okay,
year.
great.
Yeah,
So do we have to write out the reaction mechanism based on?
no,
Okay, great.
no, you'll be given, you can only be given the number, like all the steps and find the overall, or, 2 out of 3 steps and the overall and find the third step, that kind of thing. Yeah,
Got it. Thank you.
you're not expected to come up with it. Yeah. This one is challenge. You need to multiply some of the steps by 2. No? You'll need to multiply some of the steps by 2. Yeah, then okay. And then you go, oh, hang on. Now I got J. What do I have to do after that one? J's don't count. Yeah. Yeah, I'm never gonna give you one like number 2 on a folks. I would never give you one like number 2 on a quiz or test. So you might as well just leave it out for now. Okay. Number 2 is a challenge. If you're like, I like challenges, then try it, but don't get worked up about it and think they're all gonna be like that. They won't be. Okay? This should be a huge chemistry weekend for you. Yes? Okay. Because I know you also have like calculus and things next week as well, right?
No.
No? Or other courses have exams, right? So you need to make sure you put in time on both, because this whole business where students are like, I only study calculus, and then when the calculus is over, then I only study chemistry. It's a terrible way of habit to get into, because you can't afford to do that. Yes. 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 So if you are not in the word, I will have to tell you. I might draw this and I can say, this is uncatalyzed. Catalyzed activation on the oh no, just yeah, yeah. Or if I no, this height means nothing, right? It's just telling me that this is.
Oh, I okay.
And oh, I have that. Wonder. Roll out, yeah. These are gonna be hot, right? Yeah. Yeah. Yeah, so this. Yeah.
Okay, because the area under the first house is big, several part of the state is not same. So if this gets wider, they could stay the same height, the area would be bigger. Yeah, exactly, so we made it wider because it. No, we're changing the height because they're just more spread out, they have a wider range. Right, and so, you know, some of the ones that were here, and then they were here. Yeah. And that-
Anyone got any questions on anything? Now's a really good opportunity. I'm going to waste my time with this. Did everybody get the review package? Yeah. And the answer keys? Okay. Yeah.
Okay. Oh, okay. Yeah.
Yeah, so there's three packets, like, also on Teams, I don't know, we're all just talking.
We're in a lot of stay. Or, private, starting. Yeah. 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 Almost Friday. Yeah. So I'll do it on. Okay, let's make sure that you get the There you go.
Anybody else need a overall review? Everyone has one? Okay. And we will not be having like an entire review class in class. Okay? So your job is to do it at home and then bring questions. I will go over questions if you have them. Okay? So I will ask you on Tuesday, I will ask you on Wednesday if you have questions. Or sorry, Tuesday, Wednesday, Thursday, if you have questions from the review.
Because it doesn't appear here, it needs to cancel out. Yeah? And same thing here, this one is not that. Yeah. All right. Oh. Number 4. I would do this, I would break my overall reaction. Because that way I'm done. So now what I'm going to do is I'm going to say, I need to have an OCR. And I can see that I already have an OCR. So that one's taken ready. So I start going through all of these and seeing if I have anything. I'm this. Oh, I have my stuff. Big bag. And go right here. So that means that in this step, there needs to be an. And then I need a minus. Do I have a scale on this? So that one's taken care of. Okay. Now what we do is we take everything else that doesn't have a check mark, that isn't in box, whatever, and we see if we can cancel it, because we don't want anything other than these ones left over, right? Because everything else has to be canceled out. So you've already done this, you've already done this, so that's great. We have an HOI. Doesn't have anything to cancel it. Anyway, it needs to go over here so that it can cancel out. Yeah. Same thing here, I'm gonna OH. Cancel it, so I'm OH here. Okay. And then finally, go, okay? If you do have problems over the weekend, you can email me and I can see if I can try and get back to you. Okay, no guarantees because I'm bad at checking my email, but I will make a note to myself to do it. When my alarm goes off at 8 o'clock in the morning, I will check. Yeah. Yeah. No, it's not gonna be able to, I'm not gonna be able to. Okay, yeah.
This one, okay, so you have,
I did.
overall reaction is this. Okay, so I like to write my overall reaction down here so I can add it up. Two C, 3 plus 3 plus 2 L, 3 plus. Okay, and I'm gonna just do this now so I don't accidentally get around it. Okay. And I say, I need to have 2 CD4 pluses. I only have 1 CD4 plus. I need to put another one here. Now, that's taken care of. Yeah, and then you'll go through and you'll do all of them, and then you'll make sure that anything that's not in the box, you haven't said is a reactant or a product, you'll have to make sure they pass it. Okay? You can do that. Yeah.
Oh, seal. These are seal. Like, you have to put seal on your choose your better say yes, bro. Oh.
How you doing?
Long weekend ahead.
I know, right? I'm feeling exactly the same way. I'm like, huh? No, that was from the 11th. No, we just gotta finish the core, the unit, so they can study with them. We will do a titration too.
No, God makes you. You are starting it.
We are starting to. Well, maybe Tuesday, sorry, maybe Wednesday. Yeah.
Oh, retarded baby. Really? It's not long.
So not.
Is it gonna be?
No, it's not. No, it's like.
I didn't eat.
It's not that long. Ish. I don't remember.
Or 15, like,
Ish.
Collegiatory was only one section. I thought maybe you were gonna collect me.
No. We're good.
We. That.
Dursu dursu.
I'm tired.
Yes, love.
I have English.
Yeah.
I asked one of the students here to like, bring me her enriched textbooks.
Mm-hmm.
But she said she didn't have them. So now I have to ask.
I can do that.
You have them? I could.
I have to print them, but I'll just print them here. You'll want like a binder to put them in because they
Of
won't be
course.
bound.
I
Yeah,
have like many.
perfect.
And I think, do you think if some of them are in Chem 11, our Chem 11, like the organic chemistry, or no, it's totally different?
So, the units that overlap are the mole. They had some extra stuff in the mole. Thank you. I would have forgotten entirely. And you're like, why do I have 3? Okay. So yeah, unit 4, unit 5, reactions, unit 6, stoichiometry. And then from 7 onwards, it gets a little
I
different,
know.
right?
They're-
And
they're-
there's 7, 8, 9, 10, 11, 12, 13.
And they did 13
Yeah.
sections. Oh, they didn't.
So they
do-
they didn't do 1, 2, and 3 because they do that over the summer.
Oh. So you tell them to do it over the summer? On their
So-
own or each part
On
of
their
the
own.
course? Oh, it's just a review for them.
It's not a review. It's like they've never, like they learn sig figs and unit conversions and they review formulas from
So-
grade 9
so
and
it means-
10.
I have already done
Yes.
most of it.
So you would have done, yeah. So,
Review for 7, 8, 9, 10, 11, 12, 13, 5, 6, 7, 7 chapters. Another course again for me.
yeah,
Yeah.
yeah.
But I have them.
I can't get them to you right now because they
Of
take a
course.
while to print, but
I
yes.
noticed you added me in AP Chem.
Yeah,
So I thought maybe with your help I could
Yeah.
survive Miss Wu.
I could also, the other thing is if you wanted to take Chem 11 enriched with me next year, you could.
Really?
Or you could just audit. You could just come in and audit, which means you just attend the course, but you don't get graded on it.
Like next year I have maybe 4 like free courses and it's,
Right.
it's as it's a spare year I have nothing
Yeah.
to do.
So, okay, so let me put it this way. You could take AP Chem with Ms. Wu, and you could take Chem 11 enriched with me.
Both together.
Sure, whatever, it doesn't matter. You have the background for both. Quite frankly, the AP chemistry course is very, very close to Chem 12, which you're taking right now,
Oh.
right? Chem
Oh.
12 and AP Chem have a lot of overlap. There's only a few
I didn't
extra
consider
things.
that many people do not like they don't take Chem 12.
Oh, the AP Chem people? No,
Yeah,
it's
yeah.
it's
Oh,
like Chem
okay.
12 AP, you get credit for Chem 12 as well.
So AP Chem and then Chem Enriched with you.
You could, yeah. I mean,
How
the first
can
part would be super boring, right? Because like it's
Can
gonna be
we-
like mole and
No.
stuff. I'm teaching English next year.
It won't be boring. I saw some like Unit 9.
Huh?
I kind of read through STEM over Unit 9.
Uh-huh. Yeah.
It wasn't boring.
It's not boring.
Yeah.
It's interesting. No, but I'm just saying like the mole, because we start with the mole.
Oh, chapter 7.
Right? So that's why I'm saying you might want to audit it rather than like taking
Yes.
the course because like for unit 4, 5, 6, 7, you'll be like, wow, this is just Chem 11.
Oh, then I'm gonna talk to my counselor about it.
So yeah.
I could take peer tutoring here, but then be a student.
Yeah.
Because I don't think if anyone needs my help.
Yeah.
Thank you so much.
We are learning. We are learning the rest of reaction mechanisms. Yep. All right, friends. Has the bell gone? Yes. So we are on page 89, 89. That's a good number. That's the year I graduated from high school. So many years ago now. I know. You can do the math on that, figure out how old I am.
You've taught since when?
I've taught since 1995,
Oh my God.
right? So 29 years now. Well, almost 29.
Wow.
I started in October of 95.
Where did September go?
Actually, that's not true. I started in September of 95. I have shoes that are older than you guys.
Wow.
Oh, yeah. I have shoes that are older than my son, and he's 21.
So I'll be like 20, like 75 or something.
I know. And you know what's funny, though? Being old is actually good. Other than the fact that your body is not quite what it used to be,
Yeah.
it's so freeing. Like, I always say that when you get older, right? Like, you're just like, I got no more to give. I got none. They're all gone. All gone. Right? And you're just like living your best life, right? It's
Yeah.
pretty awesome, actually.
That's so real.
So, you might gain a few pounds, your knee might be creaky, whatever, but your mind is freed, right? It's very lovely, actually. All right, so this is page 89. Did I get it right? Yes, I did.